Off of trigonomic ratios, we have some triangles that will be missing parts. So we will solve those and then go on to our ratios. So, and then the opposites, cosecant, HO, secant, HA, cotangent, AO. So our combinations are the same. So if we have a triangle, a right triangle specifically, and we have 10, 6, and then we're missing a side, and then let's say we have 43 degrees, and then we have A, B, C. So we want to solve angle A. We want to solve the missing side AB, and then we're going to do our 6 ratios. So first thing you want to do for the angle, since this is a 90-degree angle, between this angle and this angle, there are another 90 degrees. So all we have to do is subtract 90 minus the given angle, which is 43. So 47. So angle A is 47 degrees. And then our missing side, we have the C side. Since we have the C side, which is the one across the 90-degree box, we're going to do the square root of 10 squared minus 6 squared, because we have C side. If we were missing the C side, we would add these two numbers, but we have C, which is 10. We're missing side A, technically, on a right triangle. So this is the square root of 100 minus 36. That gives us square root of 64, which is a perfect square of 8. So this missing side is now 8. And then now we can go ahead and do our ratios like we've been doing them. So the reason why we have to solve the missing side is just to practice, because the next section, we will have to find that missing side to do the next section. But for this part, we're still doing our ratios the same. It's just a matter of you practicing finding what's missing. So sine, I'm gonna have a sine of angle A, cosine of 43, tangent of angle A. So remember, there's a mix of two different angles, so we want to make sure that we're doing opposite over adjacent for the right angle, or whichever ratio that we're doing. We're going to do cosecant of 43, secant of A, and cotangent of 43. So I put A because we didn't know what A was. We know that A is 47 now. So you can change A to 47 when you write it down if you want to, but it's the same thing. So sine of A, sine is opposite over adjacent, so we're doing this combo up here. Sine of A is 47, so we're doing opposite, so 6 over H. H is our hypotenuse, which is 10. So remember, in a regular fraction, we want to reduce it if we can. I can reduce this with 2. So that's going to make it 3 over 5. So reduce your fractions where you can. Cosine of 43. Cosine is adjacent over hypotenuse, but we want the adjacent of 43. So the hypotenuse, we know it's 10. Again, the hypotenuse is C side. This is always the hypotenuse. So that will not be our adjacent. So this is 10 on the bottom. Adjacent to 43, adjacent is the neighbor, so 6. So it happens to be the same thing as the one on top, so we're going to put the same fraction, 3 over 5. Tangent of A, tangent is opposite over adjacent for A. So opposite is 6 over adjacent is 8. 6 over 8 can be reduced with 2, which becomes 3 over 4. Cosecant of 43, cosecant is h over o, hypotenuse over opposite, so h over o. Hypotenuse is 10. Opposite to 43 is 8. So we want to reduce that with 2, gives us 5 over 4. Secant of A is hypotenuse over adjacent. Hypotenuse is 10. Adjacent to A, which now is 47. Adjacent is 8. So this one again happens to be the same thing as the top. This doesn't always happen, so don't just like copy the first two, because both of these ended up being the same. It's not always going to end up that way. So don't think that it's related. Just make sure you go through the ratios properly. Cotangent of 43. So we're doing A over O. A over O for 43. So A is adjacent over O, opposite. So 6 over 8, which we want to reduce with 2. That's 3 over 4. So same thing that we did last section for ratios, but now we're just solving a missing angle, and we're practicing missing side just to prepare us for the next section where we do have to find those missing angles. The only thing that changes here is if we have a hypotenuse that's a radical, which I'll do one of those as well just to practice. And then we have to fix it like we did last section. So if you need a refresher, go to the last video, and that explains like the fixing the radical. But I'll do one of those now. So go ahead and pause the video if you have to copy this down. I'm going to erase it. All right, so go ahead and pause the video real quick, and then you can copy that down. So the first thing we want to do is solve the missing angle and the missing side. So remember that since this is a 90-degree triangle, all we have to do is do 90 minus the missing angle, or the given angle, which is 73. 90 minus 73 is 17 degrees, so that's n. So that's just us solving that missing angle. That doesn't go into our ratios. And then LM, for LM, we have C side, the one directly across the 90-degree box is 12. So we do have C side. So we're going to do 14 squared. Actually, no, wait, hold on. Let me do these backwards. Actually, I wrote them backwards. So 14 and 12. So we're doing 14 squared minus 12 squared. So I'll go back up in a second. So 14 squared is 196. 12 squared is 144. So remember that we're doing 14 times 14, 12 times 12, not 12 times 2, not 14 times 2. 196 minus 144 is 250, so 52, square root of 52. So in the previous video, we do break down the square root of 52, but we don't have to for this part. At least not this section. The next section we will break down everything and all that stuff. For just this section, we're gonna keep it as it is, and then when it comes out of the box, if we have to reduce the fraction, we will. So don't break down the number, just leave it as it is, unless it's a perfect square. So we're just going to use this as our missing side, square root of 52. So now we can do our ratios. So sine of 73. So sine is opposite over hypotenuse. Our hypotenuse is 14, which is the C side right across the 90-degree box. So this one will be H. Remember that the other two are both opposite and adjacent. So only label the 14 if you want to label it. So opposite of 73 would be 12. So 12 over 14. Remember to reduce this. We can reduce it with 2. And that will be 6 over 7. And then we have cosine of n. Cosine is adjacent over hypotenuse. Hypotenuse again is 14. Adjacent for 17 is 12. So 12 over 14. So same thing as the top, 6 over 7. Tangent of 73. Tangent is opposite over adjacent. So opposite over adjacent. So 12 over the square root of 52. So remember that this is what we did in the last section. If we have a radical at the bottom, we have to bring it up. So it will be 12 square root of 52. And then we keep that same number at the bottom. Here, we will reduce the 12 and the 52. So we can reduce the 52 on the inside, but again, we're not going to do that for this section. We're going to do that for the next section. So for the outside, 12 and 52, we can divide it with 2. We can divide it with, I think, 4 as well. Let's do 2 first. So that would give us 6 and 26. And then we can reduce 6 and 26 to 3 and 13. So let me scoot this over. So our final answer for tangent would be 3 square root of 52 over 13. After reducing 12 and 52 by 4, technically I reduced it with 2 twice. So that's tangent. And then cosecant of n. Cosecant is h over o. So hypotenuse is 14 over opposite for angle n, which is 17. Opposite would be square root of 52. So we're going to do the same thing that we just did with the tangent of 73, but with 14. So we're gonna bring up the 52. So we're gonna have 14 square root of 52 over 52. And then this one we can only reduce it once with 2. That's gonna give us 7 and 26. So our final answer for cosecant of n is 7 square root of 52 over 26. Secant of 73. Secant is hypotenuse over adjacent. Hypotenuse over adjacent. So our hypotenuse was 14. Adjacent to 73 is the square root of 52. Square root of 52. So it'll be the same answer that we have at the top, 7 square root of 52 over 26. And then a cotangent of n. Cotangent is a adjacent over opposite of n. So opposite over adjacent would be 12 So this one, we don't have to fix it because that square root of 52 is at the top, not at the bottom, so we don't have to bring it up. So our answers for these are 8 answers. We have the answer of the missing angle, we have the missing side, which was square root of 52, and then we have 6 over 7, 6 over 7, 3 times the square root of 52 over 13, 7 times the square root of 52 over 26, same thing for the bottom, and then square root of 52 over 12. So it's a mix of things that we just did in the previous section. The only thing is that we're adding on solving the missing angle, but everything else is exactly the same as the previous section. So if you have any questions on that, let me know, and then go ahead and do your practice assignment on Google Classroom.